Welcome to this first exercise of surface water hydrology concepts, which will mainly focus on rainfall losses. As you know from the theoretical lectures, our main driving force of the hydrological cycle is precipitation. Now, not all of this precipitation will actually contribute to the storm runoff and will go to the river. Some of this is actually lost, which we will call rainfall losses. These losses might be infiltration, evapotranspiration, or some other types of losses. Let's recall first a little concept of rainfall, namely the hydrograph. A hydrograph represents the rainfall as a distribution of measured pulses over time and would look a little bit like this. Now, every bar on this graph actually represents an amount of rainfall or a rainfall rate during a certain period. This period can be 5 minutes, 10 minutes, half an hour, 1 hour, depending on how the rainfall is measured. The rain itself on the y-axis will be either a rainfall amount, which will be designated as capital I, and this will be a volume of precipitation over the total time step. Another way of representing it would be the rainfall intensity, and this will be designated as a small I and is expressed in millimeters per hour. This is not a volume, this is a rate, which means that you actually have a volume per time unit. So even if you have half an hour period that an intensity is given, this would actually represent to an average amount of rainfall over that time. Now, what we are actually looking for is not the actual rainfall, which is measured, but the net rainfall. And this net rainfall is the amount that remains after the losses. If we have a type of reservoir and what comes in is our actual or effective rainfall, we might have losses like interception, wetting, depression storage, evapotranspiration, or infiltration. And if we subtract all of these losses from the amount of rain that comes into the reservoir, we actually get what we call the net rainfall. The general equation for the calculation of the net rainfall is given as follows. INT being the net rainfall is equal to IT, the actual rainfall, minus all of these losses. Interception, II, wetting, IW, depression storage, ID, evapotranspiration or evaporation, E, and infiltration. What we are also interested in very often is the hydrograph. This is a representation of flow at a certain location in the catchment that evolves during time. Now, we are actually more interested in one part of this hydrograph, namely the storm runoff. And this storm runoff is a direct and immediate consequence of the storm. Oppositely, the base flow, which is the part of the hydrograph without the storm runoff, is actually the flow that would be present when there was no storm. An important concept that we should keep in mind is that the volume of the storm runoff is actually equal to the total volume of the net rainfall. Now, during this exercise, we will actually look at the rainfall losses and how to go from actual rainfall to net rainfall. In part 1 and 2 of the exercise, we will calculate a global loss. and in the third part we will calculate an infiltration loss. This is because infiltration losses often have the biggest share of the total rainfall losses. And that is why, for example, in rural areas, the chances of having a flood are smaller than in urban areas, because you have more capacity of infiltration in rural areas. Now for the assignment. The data of a rainfall storm and the corresponding instantaneous discharge at the outlet of a river basin with an area of 27.4 square kilometers are given below. On the left-hand side, you see time periods, so a block of 0 to 30 minutes, a block of 30 to 60, etc., and the corresponding rainfall during that period. So between minute 0 and minute 30, a total volume, look out, it's expressed in millimeters, so a total volume of 3.3 millimeters of rain has fallen. The next time step, from 30 to 60 minutes, the precipitation total was 6.6 millimeters, and so on. At the right-hand side, you see the measured discharge. At the initial time 0, the discharge is 6 cubic meters per second. Half an hour later, you have 11.49, and so on and so forth. Now the questions that we will answer will be: first, derive the net rainfall hydrograph for this storm, considering the base flow to be constant. A, using a runoff coefficient, and B, using the phi index method. As you remember from the theoretical lectures, these are methods for global losses. What we will do is we will neglect hereby the initial losses. Another question will be to comment on the differences, the advantages, and the disadvantages of both methods. The second question will be actually the same as the first, but instead of having a constant base flow, we will consider a variable, linearly increasing base flow according to the straight line separation method, which we saw in the first lecture. You do the same thing as for question 1, being calculating the net rainfall using a runoff coefficient and using the phi index method, and also we comment on the differences between the two results. The third and final question, you will apply the Green and Empt method and the Meinen-Larsson scheme. So we will derive the net rainfall hydrograph by calculating the losses by infiltration by using the Green and Empt method. There are some properties or parameters that we need for that, and those are given in this assignment. So now we go to the first part.